Hi everyone, let's solve today's daily challenge, that is linked list cycle. So in this question, we are given the head of a linked list and we need to determine if this linked list has a cycle in it. Right, so what does a cycle mean? It basically means, see, normally what a linked list looks like is this, right? You have certain nodes and your last node is always pointing to null. Now let's say if this node doesn't point to null, it points to another node, let's say here inside of the linked list. So you can see that there is no end of this linked list and it has a cycle in it. So this is the cycle, right? So in this question, we need to determine if this linked list that is given to us has a cycle in it or not. So they have told you what is the cycle in the linked list, right? And okay, and we are also given this pause basically means where that cycle is, right? So let's say in this test case you can see that from this last node, right, the cycle is at position 1, right, and here it's at position 0. In this case it's nowhere, so position is -1 because there is no cycle in it, right? So the pause is not as such important to us, it's just written in a way to let you know what a cycle is, where the cycle exists. Okay, so the question is only we need to determine if there is a linked list cycle. Okay, now let us see how we have to like go about it. So a very naive approach that comes to our head while looking at this question is that, see, you have these nodes, all right, and it's having a cycle here. So we can do what is, we can hash these values, right, or store these values somewhere and keep checking if this value has been visited, right? So we can take a hash map or hash set, anything that you can take, right, and simply keep these nodes there. So let's say this node is having an address x, y, z, and xyz, let's take it as t, and then it is going to y. Now what we'll do is we'll keep all these nodes, we'll start iterating in the linked list. Okay, so first, now the reason I'm taking address is that node values, if you try to hash these node values, they might be same, so that will not give you the correct result. So instead, using the addresses or these node values, right, so these are the addresses of these nodes, you can, that is never going to be the same because every node is different, right? So what you'll do, put the address inside of the hash map, right? Go on to the next node, and this is y, put it also here. Then go to the next node, that is z. Then go to the next node, t. All right, so up till now everything is good, right? We haven't came across any node that has been repeated, right? So now after t I will go again to y, and I can see that y already existed. That means I have to return true in this case, that is a linked list cycle is present, right? Now in case there was no linked list, right, then what would have happened is, see, x, y, z, or oh sorry, this is t. So you would have just put all these values and you would have never found any value that is a duplicate. That means you can simply return false in this case, and before you do anything you'll reach null in this case, right? You will reach the end of the linked list, so you'll break out of that, right? And inside of a linked list which has a cycle, you will never break out of the loop unless and until you find the cycle, right? You find a node that has been repeated, correct? That's when you will be coming out of this loop, and for this condition you will be coming out of the loop as soon as your next pointer or your current node becomes null. All right, so this is the first approach. Now in this approach, the time complexity will be big O of n and space complexity is also big O of n. Now is there a way to, reduce this time complexity? What is the most optimized way to solve this problem? So that way is, so the most optimized way in which we can solve this problem is Floyd's cycle detection method. Okay, so this algorithm was obviously given by someone named Floyd, right? So Floyd detection cycle algorithm. So this is what we're going to use. Now, what is this algorithm? This algorithm says you have to take two pointers, okay? One pointer is known as slow and the other pointer is known as fast. Initially, they both are supposed to be present at the head of the linked list. So that is this position. Okay, so both S and F are present here. Then he said what you have to do is iterate inside of the linked list, start iterating, and check if F until F becomes null. Okay, keep iterating in the linked list, right? And what you have to do is you have to move the slow pointer by one distance and the fast pointer by two distance. Okay, so what that means is in the next iteration, slow pointer must be present here and fast pointer must be present at 1, 2. That is 2 units after. Right. So he said if there would be a cycle in the linked list, right, what would happen is there would be a time, right? You'll keep iterating. First of all, it will be a you will not break out of this particular loop, right? If you're still you are iterating inside of this linked list because there is no null pointer, right? So you don't know where it ends. There is a cycle, so you'll keep going circle inside that cycle, right? So you have the slow pointer, fast pointer. He said when slow pointer becomes equal to fast pointer, right, you will break out of the loop, and that's when you will know that the linked list that you have has a cycle in it. Okay, so that happens when the slow and fast pointer becomes equal, and this will definitely be the case. That is what Floyd said. Now how come this will be the case, right? Let's see in this particular test case, right? Let me take a different pen. So your slow pointer is here, your fast pointer is here. In the next iteration, where will your slow pointer be? It will be here. Where will your fast pointer be? So 1, so 1 unit, 2 unit, it will be at this position. Again, they are not at the same position. In the next iteration, what will happen? In the next iteration, slow pointer will be present here, correct? And fast pointer will be where? So fast pointer currently is here. So it will move by 2 units, that is here. So here you can see that on this very node, the slow and the fast pointer have become equal, right? And this is when we will break out of this loop and say that this particular linked list definitely contains cycle. Now, in case you have a normal linked list that when you have a null pointer here, so what will happen is, see, your fast pointer is moving 2 times the speed of the slow pointer, right? So fast pointer will reach null. That is why we are checking this condition. So this condition will never become true in this case, right? So in case the linked list is normal, you will always reach, your fast pointer will always reach this null pointer, right? So that way you will know that okay, now my fast pointer has become null. That means there was no cycle in the linked list. But if there is, your slow and fast pointer will eventually become equal. Now why is that the case, right? That is what we want to understand. And it is the case that now see, we might think that okay, seems a valid approach, but the time complexity wouldn't it be huge? But the answer is the time complexity is only big of n in this case, right? So how come, right? Why it is only big of n? And see, the space complexity will definitely big of 1 because we are only using 2 pointers and nothing else. So why does this algorithm works like this? And first of all, why does this algorithm is even valid? Like, what is the logic that fast pointer is moving by 2 units and slow pointer is moving by 1 unit, and they will definitely, become equal if there is a cycle in the linked list? Why not fast pointer is, moving 3 times the speed of the slow pointer or any other integer number? Why only 2? Right? So these questions might come to you. So let's answer them. So let us take this, right? I'm only taking the cycle part of the linked list. Now I'm going to mark arbitrary positions. Okay. So let's say here the slow pointer is, and this is where the fast pointer is. Now, if fast pointer, if we think about it, fast pointer has to become equal to the slow pointer, then what you have to do is you have to complete this gap, right? Fast pointer has to catch up to this gap. Now let's say this gap is some value x. Okay, if this gap is some value x, now let's say slow pointer, obviously it moves by 1 unit, correct? It moves by 1 unit. Slow pointer might be here, moves by 1 unit. That means as the slow pointer moves, right, in one iteration, what is going to happen? Slow pointer moves by 1 unit. So that means the gap is increased by 1. But at the same time, within the same iteration, the fast pointer moves by 2 units, right? It is moving how many times? 2 units. So that means your gap will now be reduced by minus 2, which basically is x minus 1. That means in each iteration, this x gap is being reduced by 1, right? So this is the reason and this is the logic of having slow and fast pointers. And now see, right now your slow is this, but initially your slow and fast were at the same position and you start iterating, correct? So let's say your fast slow pointer was here and your fast pointer was here, something like this. So you are going to cover n minus 1 distance using slow and fast pointers to detect this cycle. After n minus 1 iterations, you can see from here also, right? Whatever this number is, it is going to get reduced by minus 1. And initially, it can be n minus 1, right? So that means that I am only going to do n minus 1 number of iteration, n being the number of nodes in the linked list. So that means my time complexity becomes big O of n. So this is the reason of having slow and fast pointers, and this is the reason that fast pointer moves by 2 units and slow pointer moves by 1 unit, because essentially you are decreasing the gap by 1 unit between slow and fast pointer. That means slow and fast pointer will definitely meet, and also having twice the speed makes sense because you are reducing the gap by minus 1. Otherwise, let's say it was, if it was 3 units, right, you would have been reducing the gap by x minus 2. So there can be a case where slow and fast pointer don't meet, right? So this is it, right? And I hope you've understood it, right? So what we do is, in the algorithm, we take the slow and a fast pointer, and then initially they are both present at the head, and then we keep iterating and keep checking until f becomes null. And in case your linked list, the nodes in the linked list are odd, you have to also check f of next pointer, it becomes null, right? Because it can be possible also. See, f came here, then f came here, but let's say it was a normal linked list, right? Where do f go? F goes after this null. Where does it go, right? So you have to check standing here only, that if f of next, is it null? So yes, it is null, so you have to stop then and there also. So you have to check if f becomes null or either f of next become null. So this is the algorithm. We keep iterating until this point, and inside of the loop we keep moving the slow pointer by 1 unit, fast pointer by 2 units, and that is how we keep doing it unless and until slow and fast becomes equal, or you exit because of these two conditions. If slow and fast become equal, then and there return true. Otherwise, you have to return false after the whole iteration is complete, because you would have eventually reached the end of the linked list because there is no cycle in it. So let us now go ahead and look at the code. Now see, the code is this. This is pretty easy. So you take a slow pointer and a fast pointer, both are pointing at head, and you are having this condition inside of the while loop. That is, either your fast pointer becomes null or your fast of next becomes null. And keep moving the slow pointer by 1 unit. Keep moving the fast pointer by 2 units. That is next of next. And in case slow and fast becomes equal, that means you have to return true. Otherwise, if this whole iteration passes, right, and this condition never becomes true, that is slow and fast, and we know it will never become true because fast is traveling by twice the speed of slow, and if there is an end to a linked list, fast will reach the end first. So that means you have to return false. So that is how you have to solve this question.